Good morning, everyone. So, to recap about the last week's session, so we were able to discuss the professional software development. So, we tackled about the meaning of software engineering, the software ethics, and we've discussed three types of case study. So, in this session, we will be tackling software processes, and topics covered are software process models, process activities, how to cope with changes, and the rational unified process. This is an example of a modern software process. So, when we say software process, it is a structured set of activities required to develop a software system. Sa daghan og mga um software processes na nag-exist, no, but tanan to sila involve specifying or specification, design and implementation, validation and evolution. So specifying, it is defining what the system should do. When we say design and implementation, it defines the organizations of the system and how to implement that system. Validation, it is checking that it does what the customer wants, right? So lisod man nga mo develop ka og system, and then at the end, ang end result kay di dito mao ang gusto sa imong customer. Then we have evolution, changing the system in response to changing customer needs. Not only the customer needs, but ang need pod sa um ato ang company, or ang need pod sa ato ang based sa kaning market bitaw, kay every now and then get change in technology, so there may be changes sa hardware, sa software, and even sa people nga mogamit. So, software process model is an abstract representation of a process. So it represents a description of a process from some particular perspective. So kung mayroon ka og software nga process, so ang maabot sa inyong mind kay na ay mga let's say shapes, na ay mga buttons, right? So para lang ma-model or ma-represent nimo ang process in that way, in an abstract nga representation. So when we say description, no, when we describe and discuss processes, we usually talk about the activities in these processes, like gina-specify nato ang data models, naga-design ta og user interfaces, and etc. And the ordering of these activities. So, ang process description may also include products, which are the outcomes of a process activity. So, we also have the functions or the roles. It reflects the responsibilities of the people involved in the process, and the pre and post conditions, which are statements that are true before and after a process activity has been enacted or a product produced. So, again, when we say process description, from the word description itself, so you will need to describe the product now in terms of its function, in terms of its outcome, and unsa pa nga mga pre and post conditions kung i-conduct na siya nga process, or if na-produce na ang output ana nga process. Yeah, tama, no? So, kung ingon magpag-process, there should be an input, and there should be an output nga i-expect na to. So, in software processes, there are two types nga pwede nato i-follow, no? We have first the plan-driven processes. These are where all the process activities are planned in advance, and progress is measured against this plan. We also have another type of processes, the agile processes. The planning is incremental, and it is easier to change the process to reflect changing customer requirement. So, ang practice sa real world, no, Most practical processes include elements of both plan-driven and agile approaches. So lisod man gud mo follow kag isa, right? Like for instance, gusto ka so your team plans to make use of the plan-driven nga processes. Lisod man kaayo mag-plan in advance kay along the way sa inyong um pag-conduct sa mga activities sa software process na agay mga changes nga moabot, no? So in practice, gagamit ta og agile and then plan driven na approaches. But then wala may tama or wrong nga software processes, no? Pero na worst. Okay. So let's proceed with the software process models. So we have three items in this chapter. We have first the waterfall model. So the waterfall model uses plan-driven model, separate the distinct phases of specification and development. Another model is the incremental development. So we have specification, development, and validation are interleaved. So maybe plan-driven or agile. We also have the last model for this slide, so reuse oriented software engineering. So the system is assembled from existing components and may be plan driven gyapon or agile. So in practice, most large systems are developed using a process that incorporates elements from, again, from all these models. So walay murag specific nga mag waterfall lang ta. Okay, mag increment lang ta. Okay, kani nga model atong gamiton, no? So naa siya incorporation with different elements from the waterfall, from incremental and reuse oriented software. So this is the stages of the waterfall model. We have the requirements definition, system and software design, implementation and unit testing, integration and system testing. Lastly is the operations and maintenance. So there are separate identified phases in the waterfall model, no? So mao ni siya ang nakita ninyo sa previous nga slide. So the main drawback lang sa waterfall model is that it is difficult to accommodate change after the process is underway. So in principle, a phase has to be completed first, no, before moving on to the next phase. So again po, maglisod sila, kailangan mahuman sa nila ni siyang first stage or the second stage, no, prior to starting the next na stage. Mo na ang drawback ni waterfall, no. So nga naman ma'am, di nila pwede ma-change, no? So during sa inyong team man god, no, sa inyong management, sa development team, you need to agree kung unsa kid nga model inyong gamiton and you need to conform with the rules. So if it's waterfall model, so mo to siya ang requirement if you will be following or your team will be following waterfall model. Kailangan humanon sa ninyo ang isa ka phase before proceeding to the next phases. Okay, so mo ni siya ang some issues of waterfall model, inflexible partitioning of project into distinct stages makes it difficult to respond to changing customer requirement. So if the customer really want to change something, there are processes pod nga i-follow nila na sila yung mga um forms nga fill outan and then kailangan ay approval ato, no, saka pa lang siya ah ma-reflect dito sa imuhang process or sa imuhang development. So therefore this model is only appropriate when the requirements are well understood and changes will be fairly limited during design process. So few business systems have stable requirements. So this model is mostly used for large system engineering projects where a system is developed at several sites. But in those circumstances, the plan driven nature of the waterfall model helps coordinate the work. So next, a model is the incremental model. So these are the stages of incremental model. So natin mga concurrent activities. So first, we have specification of requirements, and then the team should um, provide the initial version, and then next is development, and then you have the intermediate versions, and then validation to come up with the final version. So in incremental development, ang costs of accommodating changes customer requirement is reduced, no? Kaya pares ani so tan-awon ninyo. So prior sa pag-develop, no, natay initial nga version, no? Saka before siya gi-develop. So marabag na-validation with the customer, no? Na-verification nga, oh, mugo na ba mi ani nga initial version? Okay, yes. Okay, so ma-reduce ang ato ang katong pag-accommodate na to sa changes sa customer kay involved man sila sa development. So the amount of analysis and documentation that has to be redone is much less than is required with the waterfall model. Also, it is easier to get customer feedback on the development work that has been done. So, in incremental development, the customer can do comment on demonstrations of the software and see how much has been implemented. So, more rapid delivery and deployment of useful software to the customer is possible. So why the customer are able to use and gain value from software earlier than is possible with waterfall process. So mga drawback of the incremental development. So the process is not visible. Managers need regular deliverable to measure progress. So if systems are developed quickly, it is not cost effective to produce documents that reflect every version of the system. System structure tends to degrade as new increments are added. Unless time and money is spent on refactoring to improve the software, the regular na change tends to corrupt its structure. So incorporating further software changes becomes increasingly difficult and costly. Another is software model nga pwede nato i-follow as a team or as part of a software development team is reuse-oriented software engineering. So this is based on systematic reuse where systems are integrated from the existing component or commercial off-the-shelf systems. So ang processes with this model are the component analysis, requirement modification, system design with reuse, development, and integration. So, reuse is now the standard approach for building many types of business systems. So, kaning when we say reuse, natay isa ka chapter po ana nga i-cover niya in detail kung unsa na siya, unsaon na siya pag-reuse. So, again, this is a very practical nga option no for the development team wherein mo gamit na lang mo sa katong nag-exist na kang component instead of starting from scratch. So these are the stages of the reuse-oriented requirement specification, component analysis. So kaning duha ka stages, imuhang gina analyze diha ang katong existing ninyo nga component, no? And thinking i-modify na siya no for reuse na pod for that specific project na inyong nga inyong i-facilitate. So we have requirement modification, system design with reuse, no? So based sa katong existing nga component unsay possible nga design na pod nga inyong buhaton diha, and then develop and integration na dayon, and then i-validate ng system. Okay, types of software components. So we have web services, no, nga na-mention nato last time. So they are developed according to service standards and which are available for remote invocation. Another is collections of objects that are developed as a package to be integrated with a component framework such as .NET or J2EE. So kani sila nga mga types of components now is very essential because dili na kailangan magsugod gud og buhat ani sa ilaha from scratch no kay there are available na with in the web no or pwede na nimo sila ma-download. So we also have standalone software systems no gina-configure for use in particular environment. So let's proceed with the process activities. So ang real software processes are interleaved sequences of technical, collaborative, and managerial activities with overall goal of specifying, designing, implementing, and testing a software system. So kung tanaw na to na PIPs, no, uh, when we say software processes, it doesn't only involve modeling, no, coding, dili lang na siya, no, but um, napod siya collaborative and managerial nga activities. So, especially if it's a complicated nga system, if it is a large nga mga systems, um, you really need the collaborative and managerial nga activities now. So as manager, you need to check on your people. You need to assess your people on the technicalities like what if na-assign mo ning isa ka tao to do the coding pero mas maayo day siya dito sa UI designing no so at least ma-assess pud nimo ang imong mga tao sa technical nga skills nila no. Okay, isa na siya. So, the four basic process activities na ang common sa tanan nga mga models like katong specification, development, validation, and evolutions are organized differently in different development processes. So, in the waterfall model, they are organized in sequence, whereas in incremental development, they are interleaved. Okay, so atong isa-isahon ang upat ka common nga mga process activities. So first we have software specification. This is the process of establishing what services are required and the constraints on the system's operation and development. So part of the software specification is the requirements engineering process. So in here you need to do a feasibility study. This is a technically and financially feasible to build. Is it technically and financially feasible to build the system? No. So prior to developing the software, kailangan mangutana sa mo no with your customer, mangutana mo kung feasible ba financially to build that system. Kasi bag nag-develop ka na nga system but then wala day kay ikagasto and then wala day kay tao nga mo work for that and then wala ang pinaka worst is kung walay mo gamit sa imong system, right? So again, parts of software specification, we have the requirement elicitation and analysis. So the question here is that what do the system stakeholders require or expect from this system? So again, during development, your customer should be involved. So should be part of the planning. So another is requirement specification. So you need to define the requirements in details. Na unsa gi output sa imong system, unsay mga kailangan nga requirements para lang ma-develop ni nga system. And then we have requirements sa validation. So it means you need to check the validity of the requirements. So these are the um stages or processes of the requirements engineering process. We have the feasibility study. So with that, your output should be a feasibility result. So once na ana si feasibility study, you can elicit and analyze na your plans. Then you have this system models nga needed for requirement documentation later on. So once na-analyze na nimo, so you need to specify na the requirements, and supposed to be output nimo din is a user and system requirements, and then requirements validation kung tama na ba to siya, okay na ba ni tanan nga mga requirements. So tanan to siya nga mga specification, ma-lay down to siya sa ginatawag natong requirements document. Okay. So next phase sa software process, we have software design and implementation. This is the process of converting the system specifications into an executable system. So again, katong gi-specify nato din nga mga requirements, ato na to siyang i-transform into or i-convert into a system specification. Yeah, sorry. System specification into an executable system. So in design and implementation, so we have this software design, no? So design a software structure that realizes the specification, and then i-translate nimo ang kana nga structure into an executable program. So how are you going to do this? So you need to um, inject the codes, no, kay para lang pag mo-click ka ana nga design or nga button, ana siya action nga buhaton. So the activities of design and implementation are closely related and may interleave. So this is the general model of design process. So again, timan alang nimo na siya input, na siya activities, and then na siya output. Okay, so sa design input natay platform information, specification of requirements, data descriptions, and for the design we have four. So three, but then integrate siya sa database design. We have architectural design, interface design, component design, and then your database design. So once okay na ni siya nga mga design activities, let's proceed now with the design output. We have system architecture, database specification, interface specification, and a component specification. Okay, in the design activities, again, we have four, right? So we have architectural design. So dinhin mo i-identify ang overall structure of the system. So the principal components, sometimes ginatawag na siya subsystems or modules, and ang ilang relationship and how they are distributed. We also have interface nga design, where you define the interface between system components. We also have component design, where you take each system component and design how it will operate. And your database design, where you design the system data structure and how these are to be represented in the database. Next is we have software validation. So VV is intended to show that the system conforms to the specification and ni-meet siya sa requirement of the system customer. Okay? Si Waterfall model, by the way, ilahan na siyang gi-modify. So, kay kung mo-follow manggug ka dito sa katong traditional nga waterfall model, na siya again limitation based sa atong discussion, right? Kay lisod pag-accommodate sa mga changes nga gusto sa customer. So with that, nibuhat silang modified nga waterfall model wherein they integrated VV or verification and validation. So with VV, it involves checking and review processes and system testing. So the testing involves executing the system with test cases that are derived from the specification of the real data to be processed by the system. So testing is the most common used VV activity. So sa waterfall model, sa first stage pa lang, na sila ginabuhat nga verification and validation before proceeding to the second stage or phase. And then from the second stage, again, if they wanted to proceed na sa third nga phase, they need to verify and validate na pod, no, to test nga okay na tanan nga mga requirements and designs. So in testing, napo tay mga stages. We have component nga testing, system testing, and acceptance testing. So the development or component testing, this is the individual component or in this testing, the individual components are tested independently. Components may be function or object or um, groupings of entities. While si system testing, mo ni siya ang testing of your system as a whole. So, testing of emergent properties is particularly important. And then we have acceptance testing. Kani siya nga testing, um, this is intended for your end users. No testing with customer data to check that the system meets their needs. So these are the stages and steps of testing phases in plan-driven software process. So the last phase sa tanan ng mga system models is the software evolution. Software is inherently flexible and can change. So as requirement change through changing business circumstances, the software that supports the business must also evolve and change. So, kano sa mahitabo ang changes or kano sa mo evolve ang software. So, sometimes mag-change ang software because natay mga bago nga law, natay bago nga mga rules, no, nga mandated by the government. So, yeah, isa na siya, no. Another is that na-changes sa technology. Okay, so sa first one nga change is sa environment nato, no, na mga factors that affects the process if in case na ay mga bago nga law and rules nga ma-take into action. And then another is if um na ay changes sa technology, say um na ay changes sa operating system. So possibly nga um ang imuhang software nga gigamit or katong tools nga gigamit nimo to develop that system is not compatible now with the current nga operating system or with the new nga operating system. So with that, kailangan nimo mo upgrade, no? Mo na as part of the development team, kailangan po ninyo piliun tong tools nga gamiton ninyo in development kay basin after 2 years, after 5 years, wala na siya support, no? Okay. Basi gipili ninyo siya because of the cost, no? Kay barato siya, but then again, wa ninyo na consider nga what na day siya support after a year or two. So although there has been a demarcation between development and evolution, this is increasingly irrelevant as fewer and fewer systems are completely new. So mo ni siya ang atong system evolution nga phases. Define the requirement, assess the existing system, and then propose changes, modify systems, and then you have now the new system. And once na nakay bagong new systems, balik na pud ka, no? Assess na pud nimo siya for changes. So that's the first part of chapter 2. So the key points of this chapter is that the software processes are the activities involved in producing a software system, and the models are abstract nga representation of these processes. So the general process model describes the organization of the software process. Example of these models include the waterfall, incremental, and reuse-oriented development. So again, class, mga summary na lang ni siya, no? Ayan.